The number one focus of any engineering project in aerospace and aviation is being ever more efficient. Building propulsion systems with longer lifetimes, which use less fuel and have lower weights, but increased performances, it all comes down to rethinking and redesigning each and every component over and over again, achieving the highest efficiency possible. In aerospace engineering, we are looking at three main goals: robust materials that can withstand the harshest of environments, weight reduction in aircraft and spacecraft, and the low volume production of very specialized parts. But even the strongest metals and alloys have their physical limitations. So, what's the next step? Take 2 minutes to understand why the Lithoz LCM ceramic 3D printing technology is the key technology right now for accessing a whole new universe of possibilities, and how it is solving some of the most prominent issues facing the aerospace and aviation industry today. Whether it's aircraft or spacecraft, aerospace vehicles operate in the harshest environments known to man. Even the toughest metals and alloys used are subject to rapid wear when exposed to extreme temperatures, permanent thermal shock conditions, high pressures, or corrosive agents. These conditions are just a few of the challenges faced by aerospace components. Traditional materials used in aerospace, such as metals or alloys, have limitations when exposed to thermal shocks, pressure differentials, or highly corrosive chemicals. The resulting premature component failure of critical parts compromises both the safety and performance of the part. So, just where can you find new factors to significantly change your equations? How can applications be changed to have better endurance while operating at improved performance levels? Where can this efficiency potential still be found? Let's have a closer look. Ceramics have long been recognized for their exceptional resistance to high temperatures, chemical stability, and superior mechanical properties. However, the complex geometries and intricate designs required in aerospace applications have historically posed seemingly insurmountable challenges for traditional ceramic manufacturing methods. Thanks to the geometrical freedom of 3D printing, ceramic parts can now be designed with the level of intricacy and precision needed for these extreme applications. Lithoz LCM technology is the key technology to building these innovative designs in unmatched quality and longevity. Using the LCM process, powerful ceramic materials such as silicon nitride, aluminium nitride, and alumina can be processed to manufacture extremely complex, high-performance parts with superior material properties such as high strength, toughness, and outstanding thermal shock and chemical corrosion resistance. So when it comes to extremely harsh environments, ceramic 3D printed parts will endure significantly longer than metal or alloy parts, and still with better performance. But endurance is not the only challenge facing the aerospace industry. Another key parameter in constructing components for aerospace and aviation is weight. Weight plays a crucial role as it directly affects fuel consumption, operational costs, payload capacity, and overall performance. The heavier an aircraft or spacecraft is, the more fuel it requires to reach the desired speed, altitude, and range. Additionally, increased weight limits payload capacity, reduces maneuverability, and impacts on environmental sustainability, a major challenge for innovators today. Clearly, weight reduction is a critical concern for the aerospace industry. But with the efficiency of metals and alloys at their limits, why and how are ceramics in 3D printed form unveiling a completely new range of possibilities? Lithoz LCM ceramic 3D printing technology, combined with the complex lightweight designs, presents an innovative and effective solution for weight reduction in aerospace applications. This technology offers several benefits, such as material optimization, complex part consolidation, and more refined lattice structures, Ceramic materials, such as silicon nitride and aluminium nitride, can withstand extreme forces and naturally possess excellent strength-to-weight ratios, making them ideal for lightweight applications. Changing from less rigid metals to ceramics offers significant improvements in material stiffness, so the thickness of your application can be reduced. With LCM technology, several single components can be consolidated into a single integrated part. By combining many traditionally manufactured parts into one and eliminating fasteners, joints, and redundant features, weight can be significantly reduced. This consolidation process also enhances structural efficiency and minimizes points of failure. Ceramic 3D printing enables the fabrication of lattice structures and internal cavities within components. Lightweight 3D printed structures, like these, provide stabilization, higher strength and stiffness, while decisively minimizing weight. So, we have seen how ceramics can withstand harsh environments and reduce weight in aerospace. But, as you know, all good things come in threes. And there is a third and final argument why Lithoz LCM ceramic 3D printing technology is revolutionizing aerospace engineering. And that is the speed with which various parts for multiple trial series can be built, already achieving the desired properties from the very first part. As an engineer in the aerospace and aviation industry, strict lead time targets and budget constraints put permanent pressure on your projects. But projects often involved the production of a small number of highly specialized parts, ranging from intricate engine parts to custom-designed fixtures and tools. Traditional manufacturing processes, which often rely on molds, usually have frustrating setup times and excessive installation costs, making them very inefficient solutions for low-volume part production. Ceramic 3D printing offers an optimal solution for the aerospace industry's need for low-volume, complex part production. And it is here that LCM technology offers impressive advantages. Take this silicon nitride impeller, for example. With a diameter of 23 millimeters, 6 of these impellers could be printed on one platform, taking 8 hours. With this example, you can successfully produce 18 different prototypes within 24 hours. Aerospace projects often requiring customized and tailored solutions, traditional manufacturing techniques may be limited in their ability to accommodate unique design specifications. In contrast, ceramic 3D printing offers unparalleled design freedom, enabling the production of highly intricate and customized parts. This flexibility allows aerospace engineers to optimize performance, functionality, and efficiency according to specific project requirements. Traditional manufacturing methods often involve major upfront investments in molds, toolings, and fixtures, making them highly inefficient for the typical small production runs in the aerospace industry. Ceramic 3D printing eliminates the need for costly tooling, reducing manufacturing costs and enabling cost-effective production, even for small quantities of parts. As you have seen, ceramics are the top choice for aerospace applications for their desirable material properties over metals, unlocking entirely new efficiency potential. When combined with the design freedom of 3D printing, high-performance ceramics can be produced with a level of complexity previously thought unachievable. Using our ultra-precise LCM technology, Lithoz is ready to make your aerospace vision a reality. Get in contact today and let's manufacture the future together.